Okay, so in the last unit, we reviewed how to do systems of equations, specifically elimination. In this time here, I'm going to focus more into something you can do if you really focus on elimination. And this is what's known as row echelon form. If we take a look at these equations here, notice how it tells us that like z equals 2. And then we could go ahead and plug z into the equation above it to get y. And then we can plug z and y into the equation above it to get x. Well, the idea is, wouldn't it be nice if all of our equations looked like this? Like when I give you a system of equation, wouldn't it be nice if it just looked like this so that you could just plug these things back in and get an answer? Let's try plugging z in. So we know z equals 2 from the bottom equation. So if I plug that into the second equation, I'd have y plus 3 times z is 2, equals 7. I get y plus 6 is equal to 7. I'm getting y equals 1. So right now I know y equals 1 and z equals 2. And if I want x, I'm going to go to that first equation here. So I have 2x plus 3 times y, so 3 times 1, plus 4 times z, so 4 times 2. And that's equal to 9. Well, 2x plus 3 times 1 is 3, plus 4 times 2 is 8, is equal to 9. 3 plus 8 is 11, so I get 2x plus 11 is equal to 9. Subtract the 11 to the other side, I get 2x equals negative 2, or x is equal to negative 1. So what that means is the final answer to this entire system is just the point negative 1, 1, 2. That's our final answer. And honestly, that wasn't that bad to get. All I did was plug z into the second equation and then plug y and z into the first equation. This is what's known as row echelon form. So it'd be nice if we can make our equations in this form, in row echelon form. To do this, we have to do something called Gaussian elimination. To be able to solve for a system of equations that is not in row echelon form, we can perform elementary row operations on the system. This procedure is called Gaussian elimination. So I have to specify here what you are allowed to do. You're allowed to change the position of two equations. So I'm allowed to rewrite the equations in any order I want. I can multiply one equation by a non-zero constant, and I can add a multiple of one equation to another. Here's what I mean by this. For the purposes of this question, I'm going to call this equation here, I'm going to call this equation 1, I'm going to call this equation 2, and I'm going to call this equation 3. I'm going to start by just doing equation 1 and adding it to equation 2, right? That was one of the things I was allowed to do. I was allowed to add a multiple of one equation to another. Just in this case, my multiple is 1. So I'm going to go equation 1, which is x minus 2y plus 3z equals 7. So I have minus 2y plus 3z is equal to 7. And I'm going to add my equation 2 to it, which is negative x plus y plus 6z is equal to 3. If I add these two equations together, I end up getting x plus negative x goes away. Negative 2y plus y is negative 1y, so I get negative y. 3z plus 6z is 9z equals, and 7 plus 3 is 10. I have created a brand new equation, and I'm going to hold off on what to do with that for a moment. I'm going to now try and eliminate the x from equation 3. See how I eliminated the x from equation 2 by adding these like this? I'm going to try and eliminate the x from equation 3. And the way I'm going to do that is I'm going to do negative 2 times my first equation. So I'm going to do negative 2 times my first equation and add it to my third equation. Sorry, that's badly written. So I'm going to do negative 2 times my very first equation. So I'm going to do negative 2 times x is negative 2x. I'm going to do negative 2 times negative 2y is positive 4y. Negative 2 times 3z is negative 6z. And negative 2 times 7 is negative 14. all I did was multiply my very first equation here, this equation number 1, by -2. I'm now just going to copy my equation 3 down here. So I have 2x, I have no y's, I have a minus 3z, and that's equal to +1. All I did was copy down equation 3 exactly as it is, and now I'm going to add these equations together. And you might have noticed that the x's, when I do this, are going to reduce. They reduce away. That's why I multiplied -2 to equation 1, to force those x's to reduce when I added later on. So -2x plus 2x is 0x. 4y plus nothing is 4y. If it helps you to think of it, think of this as a 0y here. 4y plus 0y equals 4y. -6z minus plus -3z is -9z. Equals to -14 plus 1 is -13. So now all of a sudden, I have these two new equations. I have this equation -y plus 9z equals 10. I have this equation 4y minus 9z equals -13. I'm going to set this up as a new system. I have -y plus 9z is equal to 10. And I have 4y minus 9z is equal to -13. So I have -y plus 9z equals 10. I have 4y minus 9z equals 13. And now I'm going to think of this, just for simplicity's sake, I'm going to think of this as my equation 4 and my equation 5. And so what I'm going to do is I'm going to do 4 times equation number 4 and add it to equation number 5. So I'm going to do 4 times equation number 4. So 4 times this top equation. So that'll give me -4y. 4 times 9z would be, what would that be, 19, 36z equals to 40. And I'm going to copy my equation number 5 just down as it is. So I have 4y minus 9z is equal to -13. And now I'm going to add these two together. I'm going to add these two equations together. -4y plus 4y is 0. -36z plus -9z is, so would that be 27z? 27z. Whoops. Be 27z is equal to 40 plus -13 is 27. And so last step is I'm going to divide 27 on both sides. I get z is equal to, in this case, just 1. I get z is equal to 1. Well, that's great, because now that I know that z is equal to 1, I can go ahead and plug z into either one of these equations here. I'm going to pick equation number 4. We had equation 4, which said -y plus 9 times z. So 9 times my z is 1 is equal to 10. All I did was copy equation number 4 down and plug in 1 for z. I get -y plus 9 times 1 is 9 is equal to 10. Subtract 9 to the other side, we get -y is equal to 1. I think I'm getting y is equal to -1. And so we got y equals -1. Now I'm going to take my y and my z and plug it into any one of these three. It honestly does not matter which of these three you pick. I'm actually going to choose the third one because I think that's the nicest equation of them all. But it really doesn't matter. Here I have 2x minus 3z equals 1. So I have 2x minus 3 times my z was 1 is equal to 1. I get 2x minus 3 is equal to 1. Add 3 to the other side, I get 2x equals 4. And divide 2, I get x equals 2. So that means my final answer, the point where all three of these will intersect, is the point 2, -1, 1. That is the point where all three of these planes will intersect. So it's worth mentioning what these solutions look like, what we are looking for. So when we're looking at this, these are what the solutions could be. So since we're talking about three separate planes, when we have a solution, they could all meet at one point. That's sort of like the example we just did, where they all met at this one point right here. They also could meet along a line, or you could have all three planes literally stacked right on top of each other. These will all produce different types of solutions. There are also multiple no solutions. So for example, we could have two planes that are parallel and a third plane that's going between them. We can have it so all three planes intersect, but they don't all intersect at one point. Or we can have it so all three planes are parallel and they never touch. So it is possible to get multiple types of solutions or multiple types of no solutions. So let's try one more. Let's say I have x minus y plus 2z equals 2, x plus 2y minus z equals 5, and 2x minus y plus 3z equals 1. And again, I'm thinking of this as my equation numbers 1, 2, and 3 while I'm doing this. I'm thinking of this as my equation 1, 2, and 3. So I'm thinking of this here as equation 1. I'm thinking of this as equation 2. And I'm thinking of this as equation 3. So the first thing I'm going to do is I notice how in equation 1 and 2, there's a positive x. So what I'm going to do is I'm going to do -1 times equation number 1. And I'm going to add it to equation number 2. I'm going to do -1 times equation number 1 and add it to equation number 2. So this will give me -x plus y minus 2z is equal to -2. That's my -1 times equation number 1. And I'm going to copy down my equation number 2, which was x plus 2y minus z is equal to 5. And I'm now going to add these two equations together. The x's will reduce. I'll be left with 3y minus 3z is equal to 3. I'm going to do something similar, but now with equations numbers 1 and 3. I'm going to do -2 times equation number 1. So -2 times equation number 1. And I'm going to add that to equation number 3. So I'm going to do -2 times my first equation, which gives me -2x plus 2y minus 4z is equal to -4. And I'm going to copy down my equation number 3, which was 2x minus y plus 3z is equal to 1. And we're going to add these equations together. So the 2x and the -2x will reduce. Positive 2y and a -y makes a positive 1y. -4z and a positive 3z makes a -1z. And -4 plus 1 makes -3. So I now have the equations 3y minus 3z is equal to 3. And I have y minus z is equal to -3. Oh, it's worth noting, this equation here, I could divide everything by 3, and this will actually just give me the equation y minus z is equal to 1. All I did was divide everything in this equation by 3. So I have y minus z equals 1, I have y minus z equals to -3. I'm going to go ahead and multiply this top equation by -1 and add it to the bottom equation. So I'll get -y plus z is equal to -1. And I'm leaving my bottom equation there alone. Y minus z is equal to -3. And if we add these together, the -y and the y reduce to make 0. The positive z and the negative z reduce to make 0. And -1 plus -3 gives us -4. So we're left with 0 equals to -4. which obviously isn't true. It's not a true statement. This is no solution. This is no solution. This is also known as inconsistent. This is also what's known as inconsistent.